So this is a prototype. So we run. So the GUI is not something very fancy, but what actually we do, we just write one piece of software, and we're going to run the same software everywhere in the different devices. And actually, what I'm going right now to show you is that I'm the only one that actually joined the network. So I don't see anybody else. So in a while, I can see myself in the overlay visualizer that we have there. So I see just only myself. In a few moments, somebody else also connects to the network running the same application, the same software, and he gets connected, and I can see actually him. So I know who is actually online. And if I want to start chatting with them, so I can create a chat room. So I create a chatting room, and this chatting room will be actually distributed to everybody else with the room that wants to connect here. And of course, we can start communicating. So I send a message. Of course, you can see that I send it because it's my laptop, but I can wait a response from somebody else if he wants to join. So by the time he sends something, I guess he sends something, I should receive it if it works.
Let's open multiple instances.
Huh?
Let's open multiple instances.
Mine? Okay. So we'll create some more instances. So the network understands that somebody else has joined, so the overlay stabilizes, so we have a new virtual infrastructure, and on top of this, we are trying to exchange messages. I think it's okay. Yes. So you send me something. So I have stabilization. So we see more devices that are connected because we create different instances. And the network has stabilized because right now we have just a ring, and it collapsed.
I closed it.
You closed everything. Anyway, it seems I'm not going to get a message today. Anyway, we can see that afterwards. Maybe try the demo once again. The point here is that we are not going to demonstrate that just because we're using laptops. We're running the same software in mobile phones, running Android. Unfortunately, we don't have the latest versions uploaded here, so we're not going to demonstrate. Panos, I'm going to move on.
Yes.
So, yes, I'm going to finish.
I can show it offline.
So we can show these offline, whoever wants to join us afterwards. But this one, turn it off. So I continue my presentation. I'm not the administrator. I guess I can join. Okay. So I had the screenshots actually. Okay. I need something. Yes. Is it okay? Okay. So I have the screenshots. I told you that it works, but not in the real time. So what you actually do, you can really exchange information, and you can see the overlay, the virtual infrastructure to be created automatically. Actually, what we believe that are the technical achievements of this prototype is that you can really achieve that without having to rely on existing infrastructure. We didn't demonstrate that here, but you can create a network by your mobile. We have tested, not mobile, in laptops. So you create a network in your laptop and you start communicating. communicating. We have zero configuration because we managed to set some of the parameters of the infrastructure that we created. We have multi-hop communication. Here it's very difficult to demonstrate that, but we can do all this kind of stuff. Autonomic adaptation of the protocols, we estimate, for example, some of the parameters of the network, like the size of the network, the degree of the network, and we adapt the protocols so we have minimum overhead regarding the messages that we exchange for control reasons. We have resource sharing, efficient resource sharing. We make sure that all devices consume the same percentage of energy, so at the end of the day you have everything to operate until the last moment where the network collapses. We try also to have distributed control. We don't allow any device to control the infrastructure. It's something like the internet per se. It's like your immunity system where the blood cells are not controlled by your brain. So we try to have this kind of techniques within the protocols that we design. And of course we need to have something that is dummy proof. We just want the user just to click, open the application and run it. So if you want to learn more about the technicalities, you can go to the reference that is here. So you can see protocol that has been developed and published in journals, and we face scalability. For example, we have simulation up to 15,000 nodes. We have hierarchical routing. We have autonomic clustering. And we have also demonstrated how we efficiently can handle the energy on the devices and how we can really estimate in a distributed manner some of the parameters of the network. And so this is just a prototype, and we consider it's a showcase. The same application, the same software, the same concepts can be applied to have a multiplayer gaming without, for example, being here and start interacting all together. We can have also offline social networking. Imagine being in the seaside, in the beach, and you don't have a network, but you can really experience the same interface when you are connected, and you are able in the beach to exchange messages. And by the time you get connected to the network, this can be uploaded. We can also have some voice communication with these techniques because it's something that also we're working on that. We also could, of course, use this kind of stuff to self-organize sensors. That was actually shown within the publications that we have. We also can consider this kind of application for distributed processing, information for smart grid applications. We try to be able to analyze 5 million users in Greece in real time. We have proposed something to the European Commission in the last call, and we hope that we get funded. Anyway, and of course we can use this ad hoc communication so you can interact with the marketing agents by the time you cross in front of the digital signs or you're just going past a shop. And there are many, many other applications. So here's the only slide that I have about IPv6, okay? And the thing is that the prototype and the design of protocols that we have done so far are based with the IPv6 in the background. So we used multicasting in our network and control protocols. We, of course, used stateless auto-configuration. Why not? We consider that is a mature technology because we had very mature implementation. It was very easy for us to find the information that we needed in order to run our protocols. Of course, this can be run on top of 6LoWPAN. We have seen that we don't have any problems to adapt our protocols to run on efficient wireless network. We don't have addressed security challenges because it's something that doesn't have to be addressed only in the physical or in the virtual layer. It's a multi-layer approach that we have to take, and this is something that we're going to do in the future. So I conclude. From our perspective, from our theoretical perspective, okay, as a researcher, we think that we need to explore new communication models, okay? And in this communication model, we should consider that autonomicity is one of the major principles that we have to take into consideration. And we need to understand that the deployment of or the development of the application has to be agnostic of the networking infrastructure. The developers should be able to write their application without having to consider if the network, if the device is moving around. Are the links reliable, and etc.? Of course, this is because we consider that the network right now should be considered as a service and has to be consumed by other services written by the application developers. And that is my last conclusion. In this process, IPv6 can be an innovation driver. So this is actually the key point that I would like to say here. It's not all the other things, but the IPv6 actually can improve the way that we write application, improve the way that we create new services. So I would like to give some credits to the European Commission, because this work has been funded partially from research projects, and also our colleagues from other teams that actually UBTech has worked on that. Thank you very much.